Inverse functions. Plus I'll record it because everybody's gone. Everybody's sick today and dying. So here we go, inverse functions. What I want you guys to understand here when you're looking at an inverse, don't write this out. Let's just look at what happens. When you're looking at these two tables, what happens for the inverse? Yeah, they just switch. You interchange x and y, okay? So when you're dealing with inverses, all you're doing is just switching your x and y values. So what we're looking at today are inverse functions, and we're working with inverse relations. So all we're doing is to find an inverse of a given equation is you interchange the x and y. Right now it says y equals 2x minus 4. So the inverse of this, x equals 2y minus 4. And then you just solve for y. That's all it is. So how do you solve for y? Add 4. Add 4, divide by 2. There's your inverse. Yeah, you could write it that way. If you want to write it like this, it could be x over 2 plus 2. Oops, it's a 1. That's an inverse. In order to find an inverse, like I said, all you have to do, interchange the x and y values, and then resolve for y. Yeah. Oh. It's basically this. Yeah, you like type through that word in there real quick? All right, guys. So let's look at another example. Find the inverse of this. I have y equals negative 2/3 x plus 6. I want you to find the inverse of that. Remember, in order to solve and find the inverse, you rewrite the equation with x and y switching, and then resolve for y. So let's see. So x equals negative 2/3 y plus 6. Subtract 6 and multiply everything by negative 3/2. I'm doing the same thing. We have negative 2/3 and I multiply it by negative 3/2, multiplying by the reciprocal. So I have negative 3/2 x plus 9 is y. That's the inverse.
Could you leave it like as if we did the other way? Could you leave it as negative x over 2/3 plus 9?
No, you don't want to leave your answers with complex fractions. Right? Don't leave your answers with complex, because that's just mean looking. Okay? So, where is this getting us today as far as the rest of stuff is going? We're getting into things like this. We're going to start talking about it in terms of function notation. Now, once again, as you're looking at function notation, all this is saying, you could probably get away with just listen to it if you just hear what I'm saying here. In order to say that two functions are inverses of one another, the following thing has to hold true. If you multiply f of x, you take the inverse of f and you substitute in for f, and you take the f and you substitute in the inverse, you should get the exact same answer. And that answer should always just be x. In order to tell if something is an inverse of itself, that means the following happens. You take the inverse equation, and you substitute in here. 2 times 1/2 x plus 2 minus 4. You solve that. I get 2 times 1/2, get x plus 4 minus 4. You get x when you simplify. When you do the same thing on the other side, take f of x and you substitute into here. 1/2 times 2x minus 4 plus 2 When you distribute that through and simplify, you get x minus 2 plus 2. Do you get x for both of these? Ladies, please take some notes. Do both of these equal the same thing? Is that same thing the variable x? Then they are inverses. That's all it means. So like you're saying, should I write all this out? No. If you have the two equations, the two functions, one of them's the standard, the other one's the inverse, to prove that they are inverses of one another, that's what you do. You substitute one in for the other. If you get x for both answers, you're good to go. They are inverses. That's it. That's called verifying if something is an inverse. And they will give you the f of x and the inverse of f of x. And they'll have to see if those two are going to be, you're just going to double check it to see if it's correct. Okay? Let me show you an example from what the book shows. It says verify that f and g are inverses of one another. Verify that f and g are inverses of one another. That means you're going to go f of g of x and g of f of x. If both of those equal x when you're done, yes, they are inverses. If they don't, they're not inverses. And just double check and make sure you didn't screw up. Yeah, they have to equal x for it to be inverses. All right? So we have f of x is 8x cubed, and g of x is x to the 1/3 over 2. So let's see here. 8 to the x of the 1/3 over 2 cubed. Now remember, I have x to the 1/3 cubed. That means the cube root of x cubed is x. So it says 8x over 8, because 2 cubed is also 8. What's 8 divided by 8? You substitute, we wind up with x. Okay? On the other side, same idea. I have 8x cubed to the 1/3 all over 2. Remember, 1/3 power means cube root. What's the cube root of 8? It's just 2. Yeah, it's 2. It's 2 to the 3rd, so it is just 2. And the cube root of x cubed is x. And 2 divided by 2 is? Are those inverses? Verifying that they're inverses, all you do is you substitute one in for the other, and the other one back in. And then I'll tell you if you wind up with x for both, you're good. Okay? Next step. Do you think that finding inverses are going to change when you have other powers, or if things are written out as in function notation, or it says f of x equals x squared? No, not at all. Now, what I want you to look at, f of x is just another fancy way of saying what? Y equals. Yeah. Remember, f of x is just a fancy way of saying y equals. So if I need to find the inverse of f of x equals x squared, it's y equals x squared. So you still do x equals y squared. When you solve for y, do you agree? Now, when you take the square root of y squared, what do you get? And negative y. Remember, there's an equal sign here, so I have to use my plus minus. So the square root on both sides. So you get all right. You can move. Oops, that didn't work. Let's say you can move the. Let me do that. No. This comes over because you can multiply or divide by the negative 1 then. But then they want that. So which answer am I only looking for? just in the positive. That's how you do that. It'll tell you. And there's a reason why you don't want the negative values here. And I'm getting to that here in a second. It's all about using your graphing calculator to see that. Okay? Yeah, you just flip-flop. Yeah. Remember, f of x is the same thing as y equals. Yeah. Yeah, because all the other examples are just straight y equals this. And so this will tell you, and you'll see this greater than or equal to 0 a lot of times when you have even powers. You'll see that a lot with even powers. Okay. So f of, I don't think that wrote up as nice as I hope. The next step in all of this, obviously, is to tell whether or not your inverse will become a function. Remember when we had functions before, and you would have to pass that vertical line test? You have to pass the vertical line test, it's a function. Well, when you're dealing with an inverse relation, you're looking at what's called a horizontal line test. Now, we all know the difference between vertical and horizontal, right? Which way is vertical? Up and down, so horizontal would be the opposite. So, here's the idea. If no horizontal line intersects the graph of the function f, your original equation, more than once, then the inverse of f is also a function. No more than once. Does that mean can it intersect it once? Yes. Can it intersect it twice? Let me show you an example of what this is. What's that? That's a parabola. It's up like a cup. You agree? Does it pass the vertical line test? Yes, it's a function. Now, is the inverse going to be a function? If I go through it this way, does the inverse become a function? Because the inverse of this is that. And it won't pass the vertical line test. See that? That's why this comes up. And it's just a matter of being able to tell whether or not the inverse itself will become a function. So all you have to be able to do is use your calculator. And if you look at your calculator and you enter in the function itself, you can tell right away if it's going to pass that horizontal line test. If it passes the horizontal line test, the inverse of this will also be a function. So let's go to this function here. F of x is 1/2 x cubed minus 2. Press it. There we go. Go to your y equals button. Remember, y equals f of x, synonymous really. Is it 1/2? Is it okay if I put 0.5 or 1/2, just for time's sake? X to the third minus 2. Will this pass the horizontal line test? I don't think it's going to work because of the values within here. Now, in order to tell for certain, you can always look at your table. Where was it at? Balance around 0. 2. No, we're going to be okay. Because this is just the one single up and around. So this will pass it. Okay? Because when you spin it, this is still just, it's just changing direction there, okay? Because as it gets to become 0, as x is 0, oops, you get negative 2. But if x is like 0.0000001, it's still going to be a different value, all right? So that's what we're looking at. Can you just use your graphing calculator to tell whether or not it's going to pass these tests? Does that make sense? What's that? What I'm looking at, you see how it almost looks like it's horizontal here? The reason why it's not horizontal is two things. See how we got all these little tick marks going down? One of those little dots is a tick mark. What I was looking for in the table itself, I was looking to see if one of my, those would be x values that repeated, but you're not going to have a repeated x value. So that way you're not getting the same y values. So I know that as it's getting closer and closer to this spot in here, it's getting closer to -2 and then it's switching away from it. That's all. It passes, yes. This would be, the inverse of that would be a function. If it doesn't pass, see how this one doesn't pass the horizontal? So this one would not be a function. This one is a function. The inverse will be a function, yes. Let me show you another one here. If we just type in this, we have f of x is 10x cubed. Same idea. Will it pass the horizontal line test? Yeah, it will. Yeah. It's just, remember, it's just changing directions at 0. Okay. So if we pass that horizontal test, that means that the inverse will also be a function. That's all. Okay. We're going to quiz on this stuff probably on Wednesday. All right, we'll probably quiz over this stuff on Wednesday for the first 4 sections. Okay. Other than that, I mean, there really isn't much more to this aside from telling whether or not it's going to wind up being a function, and then tell me what is the inverse of 10x cubed. I want to find out what the inverse of 10x cubed is. So see if you can figure that out real quick before because I think it's about all I wanted to go through. Let's tell you the truth. How do you undo cubing the cube root? Now remember, does it like to have cube roots in the denominator? No. So what would I have to multiply it by to turn it into a perfect cube? Think about 10. What's 10 cubed? 1,000, okay? So in order to turn this into a perfect cube root, you'd have to multiply this by 100. You agree? So that's where you get the cube root of 100x over 10. You want to turn this into a perfect cube, and the easiest way to do that with the power with a 10, just cube it right away, figure out what it is, and then that way you know what you have to multiply it out by. Okay? And there's your inverse. Now, as we get further into this, not in this section, but a little bit further on, we'll start graphing them as well. Because we'll start graphing cube roots and all that other stuff after we take our quiz. So tonight, what I'd like you to do is on page 426. I'm giving you a little bit of time here. I mean, it's not a lot, but let's see. 16 to 32. And 36 through 46 evens. Okay? Yeah, evens on both of those.